In the depths of the night, a hidden world awakens, revealing a spectacle that seems otherworldly. Waves shimmer as they lap against the shore, casting an ethereal glow across bioluminescent bays. This light is no mere coincidence, it results from intricate chemical interactions that sustain life beneath the waves. A deeper question arises: what mechanisms lie beneath this radiant phenomenon? Bioluminescence originates from a biochemical reaction involving luciferin, a light-emitting molecule, and luciferase, an enzyme that catalyzes the reaction. Not all organisms glow. The secret lies within specific species of plankton, jellyfish, and marine life thriving in these glowing havens. Each organism has adapted this skill for various purposes. Some attract mates, while others use it as a defense against predators. The shores of Mosquito Bay in Vieques, Puerto Rico, are among the most famous bioluminescent spots, where millions of tiny dinoflagellates illuminate the water with a radiant blue hue at the slightest disturbance. These bays embody intricate relationships that sustain marine life and highlight the delicate balance of these ecosystems. The glow acts as a signal, warning predators and facilitating survival. The complexities of marine interactions reveal how light dictates life in these luminous waters, where every flicker serves a purpose. But what happens when this balance is disrupted? Climate change, pollution, and habitat destruction threaten these serene environments, posing risks to the very organisms that create this stunning light. As we explore bioluminescent bays, we must consider the broader ecological narrative they represent. Their shimmering glow is a stark reminder of the interconnectedness of life in our oceans and the urgent need for conservation. At the heart of these glowing waters are tiny organisms known as dinoflagellates. These single-celled protists produce light through a chemical reaction involving luciferin and luciferase. When agitated, they unleash an ethereal glow, illuminating the water with ghostly light. Imagine gliding through a bay, each movement triggering a cascade of luminous sparks, creating a surreal landscape. It's as if the stars have descended to dance upon the surface of the water, a mesmerizing display of nature's artistry. Research reveals that the light emitted is not random, it is a calibrated response to environmental stimuli. This bioluminescence plays a critical role in survival, acting as both a defense mechanism and a communication tool. The enchanting jellyfish gliding through these waters also possess light-emitting capabilities, dazzling with their bioluminescent beauty. The ethereal glow of the jellyfish can act as a deceptive lure, drawing in curious fish that become entrapped in their delicate tentacles. Historically, the phenomenon of bioluminescence has fascinated humankind for centuries. In ancient Greece, the philosopher Aristotle documented glowing sea creatures in his works, likening them to spirits of the sea. His observations laid the groundwork for future explorations into this luminous world. Fast forward to the 19th century, when bioluminescence captured the imagination of the scientific community. In 1868, the British naturalist Edward Forbes referred to the glowing ocean as a wonderful display of lights. His awe-filled descriptions reignited curiosity about the deep and dark waters of the ocean. As scientific inquiry advanced, researchers like Sir John Murray in the early 20th century began to classify and study these glowing organisms in earnest, unveiling their role in marine ecosystems. Their expeditions into the depths of the ocean revealed not only the existence of bioluminescent life but also its interconnectedness with larger ecological systems. Murray's work paved the way for future marine biologists and oceanographers who would probe deeper into this shimmering abyss. The delicate glow of bioluminescent bays is not merely a visual spectacle but a complex tapestry weaving together countless interactions. Bioluminescent organisms often rely on specific environmental conditions to thrive: warm waters, proper salinity levels, and nutrient availability. For instance, when the nutrients from decomposing organic matter seep into the water, they create a fertile ground for microscopic life to flourish. This nourishment, however, can have unintended consequences. As nutrient levels rise, it can lead to harmful algal blooms that choke out the very dinoflagellates responsible for the luminous displays. A poignant example of this can be traced back to the year 2015 when a record-breaking bloom of Carenia brevis, a harmful algal species, devastated the coasts of Florida and Puerto Rico. Local fishermen watched helplessly as their catches dwindled and the bay's glow faded into an eerie darkness. The once vibrant bioluminescent bays dimmed, overshadowed by the toxic algae, leaving a haunting silence where there was once a cacophony of life. The cascading effects of these ecological shifts ripple through the food web, showcasing the fragile connections that bind life together in these waters. Even larger organisms participate in this luminous ballet. The lanternfish, a small but vital player in the oceanic food web, possesses light-producing organs called photophores. These organs enable the lanternfish to navigate the deep, dark waters of the abyss, attracting prey while evading predators. As they ascend from the depths at night, the glow they emit serves as a beacon in the dark, facilitating communication among schools. Recent studies suggest that these displays may even enhance coordination during hunting, allowing them to work together more effectively. Imagine schools of lanternfish moving in unison, their synchronized glow painting a mesmerizing picture against the inky backdrop of the ocean depths. Yet, the beauty of bioluminescence is under threat. As climate change alters ocean temperatures and disrupts currents, bioluminescent bays face unprecedented challenges. Warmer waters lead to harmful algal blooms, diminishing dinoflagellate populations and releasing toxins that threaten entire ecosystems. Pollution worsens these issues, as waste infiltrates fragile environments, suffocating their brilliance. Plastic debris, agricultural runoff, and untreated sewage create a toxic cocktail that endangers the delicate organisms that call these bays home. One startling example comes from the coastal waters of San Diego, California, where rising temperatures and increased pollution levels have led to significant declines in bioluminescent dinoflagellate populations. Reports from local biologists indicate that the once plentiful displays have diminished dramatically over the past decade, highlighting the urgency of the situation. In 2022, researchers documented a 60% decrease in bioluminescence along certain beaches, underscoring the fragile existence of these organisms. This decline is not just a statistic, it reflects the erosion of a delicate marine ecosystem that has persisted for millennia. Yet, there is hope. Initiatives aimed at protecting bioluminescent bays emphasize sustainable practices and habitat preservation. Organizations like the Caribbean Conservation Corporation actively engage local communities in conservation efforts, promoting better waste management and reducing plastic use. In Puerto Rico, educational programs have emerged, inspiring residents and visitors alike to appreciate the allure of these glowing waters while taking action to protect them. Responsible tourism practices, such as guided night tours that minimize disturbance to the bioluminescent organisms, help foster a culture of respect for these fragile ecosystems. By promoting awareness and fostering a sense of stewardship, we can work towards preserving these luminous landscapes for future generations. It is not merely about enjoying the beauty of nature, it is about recognizing our shared responsibility to protect it. The allure of bioluminescent bays serves as a testament to the wonders of nature and a reminder of the fragility of life. The flicker beneath the surface calls us to action, a plea to honor and protect aquatic realms that sustain us. Each glow encapsulates a story of survival, beauty, and the intricate tapestry of life in our oceans. As we delve deeper into the mysteries of these hidden gems, let us recognize that the preservation of such wonders is not merely an obligation but a legacy we owe to the planet and ourselves. The ocean's call beckons us to protect these luminous waters, for in their glow lies the heartbeat of life itself.